Okay, so this is 2005 Mechanics 1, and it's an air resistance problem. It's not super in-depth, but it'll give you a pretty good idea. Anyway, a ball of mass M is thrown vertically upward with an initial speed of v naught. It experiences an air force resistance given by F negative kV, where k is a positive constant. The positive direction for all vector quantities is upwards. That is going to be important. Okay, express all algebraic answers in terms of, I'm going to do this in a different color, M, K, and V naught. Here, I'm going to come write that over here. M, K, V naught. You see that? That is what your answers need to be in. If your answers aren't in that, and they're in whatever you want to put it in, or they're just like whatever, yeah, no, they have to be in this. Esteban. Anyway, and many others. So just kind of like, let's kind of lay out what's going on here. So you've got this ball that is thrown up into the air with an initial velocity of v naught, right? It's traveling upwards. Now we know that the weight is going to be acting on it. And don't forget that they have defined up as positive. Sometimes on air resistance problems, it's useful to look at down as positive, like your ground, but in this case, they've defined it for you. So also remember on air resistance. Now, if you look at this F is negative kV. It looks a lot like Hooke's law, you know, spring force. And it acts a lot like that. And also like friction. I like to think of it as friction because it's essentially air friction. You know, friction can act in different ways. Like if you slide down the slide, you get like a wedgie. But if somebody pulls you up the slide by your hands and your feet are pointed down the slide, you know, it can pull your pants down if they're loose. Air resistance is kind of like that. It pretty much opposes what you're trying to do. It's a good way to think about it, I think. So anyway, this is your force of air resistance. Now notice it is dependent on, this is a constant, so the thing that it really depends on is your velocity. Keep that in mind. So you've got your free body diagram here. I'm going to just write this as kV. Well, maybe. Okay, so that's your free body diagram, weight, and kV. Okay. Anyway, that's kV. If it disappears again, it disappears. So anyway, they want to know, does the magnitude of acceleration of the ball increase, decrease, or remain the same as the ball moves upwards? Notice this says acceleration. And yes, I know what you're thinking. Well, when you're throwing things in the air, it's always negative g for acceleration. Yes, if it's in free fall, which means that gravitational force is the only force. That is not the case. This is not in free fall. So let's think about what happens. Well, what's going to happen? Acceleration always follows force, or net force. So net force is, you know, directly proportional to acceleration. Anyway, so you're going to have your acceleration downwards. That's going to stay constant. That's your weight, or your acceleration due to gravity. This one's dependent on speed. Now, as this goes up, you know at the top of its trajectory here, velocity is going to equal 0 at the very top. So this is actually slowing down. So this v is getting less. So what's happening is that since your force, your air resistance force, I'm going to put force air, okay, is directly proportional to v, v is decreasing. Therefore, just your F air is decreasing. Therefore, net force, I would write decreasing, I just ran out of room. On the AP test, write decreasing. Therefore, net force, which equals weight minus kV, is decreasing. Therefore, acceleration is decreasing. I would have actually written out decreasing. So that could be your justification. Oh yeah, and it's decreasing. But I would say something to the effect of, like, just doing this. Oh, and I should have also written, and net force equals mass times acceleration. If you see that you might do this further on down here, I would always, you can always like work the problem further down. That's probably what I should have done, because I bet you they asked this. Work the problem further down and then draw an arrow back up here. All right, I'm going to do these in sections. I think that'll be faster.